Solving quadratic equations by graphing. Our objective is to solve quadratic equations by graphing. Who uses this? Dolphin trainers can use solutions of quadratic equations to plan the choreography for their shows. Remember, a quadratic equation can be written in the standard form ax squared plus bx plus c equals 0, where a, b, and c are real numbers. And remember, a cannot equal 0 or you do not have a quadratic function or equation. When solving quadratic equations by graphing, we need to first write the related function, then graph that function. Step 3, look at your graph and find the zeros. The zeros are the solutions you're looking for. Let's practice. So we have 2x squared minus 2 equals 0. We want the related function. This is the function that we're going to graph. So we have y equals 2x squared plus 0x minus 2. This gives you a placeholder when you're trying to graph, when you're using your vertex, your y-intercept, and mirror imaging that over. So take a moment and graph this function like you learned how to in previous sections. Now that you've graphed the function, find the zeros. So you're going to look at your graph and find your zeros. In this case, you have one at -1 and 1. You can double check by plugging those values back in. So 2 times the quantity -1 squared will give you 2, minus 2 gives you 0. And then when we plug in 1, 2 times 1 squared minus 2 is still going to give you 0. So yes, we're good to go. Take a moment and pause the video and try this next one on your own. When you return to the video, the answer will be revealed below. So you've made the related function, and then you've graphed your function. Here's a hint. Find your axis of symmetry, plug that value back in to get your vertex. Then look and find your y-intercept, which would be this -4 here, and then pick a random point. I happen to pick -1 because a lot of the graph was off to the left-hand side here. Once you do that and you have your graph, you now look for the zeros. In this case, you have a 0 at -2. You can double check. So we have minus -2 squared, minus 4 times -2, minus 4. And all that together ends up giving you 0. So yes, we're good to go. Now try using a graphing calculator. So step 1, you need to write the related function. Once you have the related function, you're going to simply put that into your graphing calculator under the y equals. Alright, so our related function would be y equals x squared minus 4x, because we need to move this to the other side, and then plus 5. And when you stick that into your graphing calculator and then hit graph, you will end up with an image that looks as such. Notice how the graph does not cross the x-axis. That means that you have no zeros. If you're having trouble viewing your graph, you may need to change your window so that way you see a closer image of right in here. So now let's try an aquatics application. A dolphin jumps out of the water. The quadratic function y equals -16x squared plus 20x models the dolphin's height above the water after x seconds. About how long is the dolphin out of the water? We need to write a related function, graph it, and then find the zeros. So our related function is going to be y equals -16x squared plus 20x. And then we graph it. So similar to the way you graphed the problem here, where you plugged in your related function into the calculator, you're going to do the same thing again. Keep in mind, if you're not able to view your graph, you may need to change your window to get a better image of what you're looking for. So once you've graphed your function, you're going to look and find the zeros. In this case, the graph starts at 0, 0, because the dolphin is leaving the water, and when it's at the water's edge, it's at 0. And we're asking, when is it going to touch back down? So when you're looking at your graph, this is where your 0, 0 is, and now you're looking for this piece here to find out how long the dolphin was in the air. So you can use the trace feature on your calculator and trace the graph until you end up with your value for this. You end up with, in this case, about 1.25. So the dolphin is in the air or out of the water for about 1.25 seconds. And that ends our video lesson on solving quadratic equations by graphing.